Hi, 8th grade. I want to do a quick review with you before your quiz tomorrow. This is Chapter 2, Lesson 4. We did rotations. We talked a lot about it on Friday. Today I was planning on us just kind of solidifying it in our minds. And then also I want to go over how to use more than one transformation. So sometimes a shape doesn't just translate, or it doesn't just reflect, or it doesn't just rotate. Sometimes it does something and then it does something again. So let's go over the rules real quick, just to remind ourselves of what we learned from Friday. Here are the rules of rotation. So pause this video, write this down if you need to, but you should have them already written. If it's going counterclockwise versus clockwise, we have two different set of rules. The only rules that are the same are the 180 degrees. Something else with 180 degrees is if I had a shape in this quadrant, remember if I rotated 180 degrees, it'll always land in its diagonal opposite quadrant like that. If I have it over here, it would land over here, and that's only for 180, okay? Don't forget that the x comma y switches for most of the rules, and then either the x turns negative or its opposite and the y turns to its opposite. Now, remember, the big thing about these is it only works if you are rotating about the origin, okay? So those were the rules that we learned Friday. I would like to go over the rest of chapter 2.4 with you guys right now. So go to page 64 in your book, and we're going to take notes on all of these, okay? The vertices of a rectangle are A, B, and C, and D. Rotate the rectangle, let me highlight this real quick. Rotate the rectangle 90 degrees clockwise about the origin. Remember, it has to say about the origin for it to rotate with our rules. Then after you rotate it 90 degrees about the origin, reflect it across the y-axis. The final question is, what are the new coordinates of the image? So I'm looking at their example. I can tell that the red rectangle is the original, and the reason why is because it doesn't have the prime markings. I can tell that the blue is the second image because it only has one prime marking. And then I can tell that green would be the second image. Okay, so it's like the final picture because it has two prime markings. So just by looking at this, I can see that from corner B to B, it rotated 90 degrees about the origin, right? And we can use our rules to do that, or you could make a 90-degree angle from the origin to the other point. It's a little harder to do that, but I would always use my rules if it said about the origin. After rotating all these points, you get this image, okay? After you get that image, then it wants you to reflect it across the y-axis. So remember, with reflection, you just count how many spaces until your line of reflection. So A is 1, 2, 3 away, so A prime prime will be 1, 2, 3 away. D is 1, 2, 3, 4, 5 away, so D prime prime will be 1, 2, 3, 4, 5 away. So you would do that with all your points, count all the jumps, and that's how you'd get your final image, okay? So your final answer would then be the coordinates of these 4 points, and that's what they got right here for you, okay? On your quiz, you will have a few that ask you to do more than one transformation. And we'll look at that too. Let's look at number 5. Describing a sequence of transformations. Now, there's going to be some just like this on your quiz. The red figure is congruent to the blue figure. That helps us know that they're the same. There could be some transformations that happened. Describe a sequence of transformations. Sequence means more than one, in which the blue figure would be the image of the red figure. So let's look at this guy right here. Red is the original, blue is the image. It wants to know how could it have landed up here. Remember, a sequence of transformations. Let's read what it says. You can turn the red figure 90 degrees so that it has the same orientation as the blue figure. So begin with a rotation. After rotating, you need to slide the figure up. So which way did they rotate 90 degrees? It looks like they just want it so that it's in the same position. So it looks like if we would have rotated this, oh, I can see how they did it right here. If I rotated this 90 degrees, it looks like they went counterclockwise this way, so that this point is now here, this point is now here, that point stayed the same, and this guy swung over to here. So now that it's orientated the right direction, I've got this new image, right? And then it said, translate that figure up to get to the final image. Now, how much did it go up? Well, that's easy. Just pick two corresponding points. It went 1, 2, 3, 4. So you would just say go up 4. There's no left or right. It just went straight up. So the final answer is, one possible sequence of transformation is a 90-degree counterclockwise rotation about the origin. Super important to say that, right? Followed by a translation of 4 units up. That would be your final answer. On the quiz, I'm going to flip over to the quiz real quick. Here's your quiz. You have 2 of those. It says the shaded figure is congruent to the non-shaded figure. Describe 2 different sequences of transformations in which that non-shaded figure could turn into that shaded figure. So basically, the non-shaded figure is the image, okay? So that's where we're trying to get to. Start here, the shaded, and try to get there. So the first thing I notice is maybe a rotation right here to get this point facing upwards. Once you figure out what that rotation would be, then it looks like a translation that way. That could happen. Over here on 8, it looks like, oh goodness, I think maybe, remember going from shaded to non-shaded, so maybe a rotation and then a translation to get it over there. So first you would rotate this using your rules about the origin, right? Use your rules and rotate it and see where it would land. I'm going to guess it would be something like, so if I had to make this a 90-degree angle, it'd be somewhere over here. Gosh, it's kind of hard for me to kind of guesstimate where it would be. It's kind of something like this. Come on, disappear. Something like that, right? Then after you find that, then I would go ahead and see how many do you have to go over and then down for it to land there, okay? But I guess the reason why I'm showing you all this is because I want your answer to look like this. I want it to have this word, these wordings. I want them to say transformations. Don't forget to say counter or normal clockwise. Don't forget to say which degrees. Don't forget to say about the origin. And then don't forget to say what the next transformation is, okay? It's a lot, I know. Maybe we could do I'm going to go look in your homework and see if there was one that we could do together. Okay, 24 and 25. Let's do that. This is on page 66 of your book. The red figure is congruent to the blue figure. Describe 2 different sequences of transformations in which the blue figure is the image of the red figure. So we're starting at red, get to blue, okay? So first thing we need to do is we need to see how can we get this red rectangle orientated upwards so that it can land over here eventually. So I think obviously the first step is a rotation, right? Now, I want you guys to go ahead and label each of these points and then tell me what their coordinates are. So let's go ahead and say this is A, B, C, and D. The reason why we're doing that is because it's so much easier to find out where everybody lands if they have a number or a name, right? So A, B, C, and D, let's go ahead and list their coordinates. A is over 1, down 2, so it's going to be 1, negative 2. B is over 4, down 2. C is over 4, down 4. And D is over 1, down negative 4. There we go. Okay, now that I've got that, I can go back over here to my notes. And let's use these rules. I want it to rotate this way, which is counterclockwise. And it looks like a 90-degree rotation is all I need. So my 90-degree counterclockwise rules are the Y turns to its opposite, and then they switch places. So let's go back over here. The Y turns to its opposite. Now the opposite of all these Y's is a positive number. Now I'm going to get a new color. How about we get blue? So now A prime, B prime, C prime, and D prime. Remember, Y doesn't just turn its opposite, they also switch places. So this is now going to be 2, 1, 2, 4, 4, 4, 4, comma 1. Now go plot those over here. So I've got over 2 up 1, that's my new A. Over 2 up 4, that's my new B. Over 4 up 4, that's my new C. Over 4 up 1, that's my new D. Now, we're looking good now, right? We have the right orientation. This is what we're looking for. Now it looks like a simple slide, right? Why could this not be a reflection? Well, if you look at the y-axis, this point is only 1 away, and his corresponding point would be 2 away. So it does not look like a reflection to me. But I could easily translate that guy over there, right? So this would now be B prime prime, C prime prime, D prime prime, and A prime prime. How far did A have to translate over to get to A double prime? 1, 2, 3, 4, 5 to the left. So here's how I want your final answer to read, okay? I want you to say, the red figure it didn't translate. First, it rotated 90 degrees counterclockwise. Then it translated, how many to the right? 1, 2, 3, 4, 5. 5 units to, the left. 5 units to the left, and that's it. That's what your answers look like. So on the quiz, when you have ones just like this, you gotta remember what we did. First, we rotated. I had to use my rules to find these new coordinates, right? Then after I rotated, I just counted how far did it slide over there, okay? But my final answer has to look like this. It has to be a little paragraph of telling me exactly what happened, okay? All right, we'll do one more. 25. How did my red triangle turn into that blue triangle? Well, first of all, we have to orientate it so that it's even just like the right direction, right, guys? So maybe let's try, in my mind, I'm thinking obviously like a rotation that way, 90 degrees. I'm also kind of wondering, what would this look like if I rotated it 180 degrees so it landed over here somewhere? I'm guessing it would be upside down, right? And then maybe I could reflect it. I don't know, it's hard for me to visualize this. So how about I go with my gut and just try a counterclockwise 90-degree rotation first and just see where it lands. So remember, the first thing I did is I labeled all these points. Say this is A, B, and C. Then I listed the coordinates. So we've got A, B, and C. A is 1, 0. B is 1, 2. And C is 5, 2. Okay, so going back to my notes, I want to go counterclockwise, 90 degrees. The Y turns to its opposite, and then they swap places. So let's go back over here. Let's make a new A prime coordinate, a B prime coordinate, and a C prime coordinate. And the Y is going to turn to its opposite, and then they're going to swap places. Now, 0 can't be an opposite, agreed? So that we're going to leave that one, but this will be -2, and this will be -2. Now swap them. So this will be 0, 1, -2, 1, -2, 5. Now let's go plot those over here and see where it lands. 0, up 1, that's A prime. B prime is -2, up 1. And then C prime is -2, up 5. So, okay, I'm liking how this is looking. The reason why is because it's orientated the correct way. So I know that 90 degrees counterclockwise was a good idea. But now how do I get B to now land over here? I'm going to call this B prime prime. This will be A prime prime, and this will be C prime prime. How the heck do I get it to go over there? Well, it looks pretty simple. It looks like it's just a translation of down 1, left 1, down 1, left 1, down 1, left 1. So let's go ahead and write our little paragraph here. So we say first rotate 90 degrees counterclockwise. Oops. Then translate, and we said it was down 1, comma, left 1. And there we go. That's it. First we rotated 90 degrees to get there, then we translated down and over. Now guys, I went with my gut instinct on that one and said, okay, let's do the 90-degree rotation counterclockwise, but part of me was like, hey, what would happen if I did rotate it 180? But if you look at it, I don't know where it would land, but I'm going to guess this would be 90 here, 90 here. I'm going to guess A prime might have landed like right here. I'd have to actually do the math and see, but I mean, we could just try it. Let's just try it, because isn't the 180 degrees super simple? It's just they turn to their opposite sign. So this is the answer. This is good, but I'm going to erase it real quick and just see what would have happened. See if there's two possible answers, right? Oh, whoops, I'm going to keep my original coordinates right there. Okay, and I'm also going to erase the negatives that I put in there. Boop, boop. Okay, so that was my originals, right? A, B, and C. Let's try my 180 switch. I'm just curious what would happen. So remember, 180 just says that they turn to their opposites. They don't swap places. Let's see, A prime would be -1, 0. So A prime would be here. B prime is -1, -2. Ugh. Ooh, goodness gracious. Okay, -5, -2. Let's see, I made a mistake somewhere. There we go, B. It should go right there. Okay, erase that mistake. Okay. Now guys, I'm not completely done. I mean, could I then rotate it another 90 degrees about point A, right? So, I mean, if I rotated this another 90 degrees about point A would land there, B would land here, and C would land here. So I guess what I'm seeing is that there are two possible answers. I could have said what I said before, or I could rotate 180. Rotate 180 degrees. Remember, it doesn't matter clockwise or anything, but I do want to say about the origin. And I think I forgot to say that over here. The red figure rotated 90 degrees counterclockwise about the origin. That's super important, because look what my second step was. Rotate 180 degrees about the origin, then rotate 90 degrees, and if it's going this way, guys, that's clockwise, about point A. Okay, now remember, that's super important, because if I rotated about the origin, I wouldn't land here, right? But because I rotated about point A, then it would land up here, and this guy would land right there, okay? So I want you to see that there's no like just one right answer. There's a few things you could have done, right? I could do so many things, but I only want a sequence of two things, right? So two ways that it could have got there is right here. That's a way right there. It's first, then the second way, right? Two different sequences does not mean give me this answer and then give me the answer I had before, okay? It just means what are two transformations that it made to get there. Okay, so that's all we are doing in class today, is just that review. Remember, on Friday, we did most of this on Friday, where we talked about what a transformation or a rotation was. But hopefully that helps you guys out for your quiz tomorrow. I'm looking at this practice quiz on page 69 in your book, and there's two questions just like those where it says what are the two different sequences of how those shapes could have got there. We'll probably do that in class today. But please watch this video, take really good notes. You can use your notes on the quiz tomorrow. And if you have any questions, please feel free to email me or ask. All right, guys, good luck.